All right, let's jump right in. We're about to crack the code on one of the most interesting cat and mouse games happening in tech right now, AI jailbreaking. And you're going to see it has way less to do with coding and a lot more to do with the human logic that's kind of hidden inside these really powerful models.
You've totally been there, right? You ask something and bam, you hit that digital wall. I'm sorry, I can't answer that. But what if I told you that for a lot of people, that wall isn't really a dead end? It's more like a puzzle. It's the starting line for a process that tells us a ton about how AIs, and even we, actually think. You see, every single major AI model comes with these built-in digital walls. These are just safety features, right? They're designed to stop the AI from spinning out harmful or unethical stuff. But you know human nature. The second you build a wall, someone's going to start looking for a way to get around it.
And that brings us to our main event, the jailbreaking prompt. Now, this isn't hacking in the traditional sense. We're not talking about lines of code here. This is all about language. It's the art of writing the perfect combination of words to basically persuade the AI to take a little step outside of its own rules.
And that's really the heart of it. This whole thing is a battle of wits, not a brute force attack. The jailbreaks that actually work are the ones that exploit the AI's grasp of language, of context, and logic. It's a lot like social engineering, but you're playing the psychological game with a machine.
So the big question is, how do you pick a digital lock using just words? Well, it turns out that the AI's biggest strength, its incredibly flexible understanding of human language, well, that's also its biggest weakness. Let's dig into the mechanics of it.
What's so cool about this is how these methods really play on the AI's core programming. Take contextual override. That just takes advantage of the fact that the AI tends to focus on the very last thing you told it. Instruction misdirection is basically tricking the AI into believing a bad request is actually a safe one. Simulation-based bypass is where you convince the AI to just act or pretend so it thinks its normal rules don't apply. And then you have token-level manipulation, which is just subtly changing words to sneak them past the automated filters. Okay, so now we get the theory. Let's actually open up the Jailbreakers toolkit and check out some of the seriously clever techniques people are using to put all that theory into practice. First up, the famous one, role-play exploits. You've probably seen these around. The genius here is you're not asking the AI to do a forbidden thing. Instead, you're asking it to pretend to be someone or something that is allowed to do it. It just completely reframes the whole request in the AI's mind. And this is just a perfect example. See, the prompt isn't asking the AI to make ransomware, it's asking it to perform a simple educational task inside a totally safe, hypothetical classroom. The AI sees the role, cybersecurity instructor, and suddenly fulfilling that role becomes more important than its default safety roles. Okay, next up is another really mind-bending technique, contradiction prompts. This one is pure psychological manipulation. You give the AI two instructions at the same time that completely contradict each other. You're creating this logical paradox that can literally short-circuit its safety programming. I mean, just feel the tension in that prompt. The AI is told, you must never do this. And then in the very next breath, okay, now do that thing for this test. This is a direct exploit of the model's intense desire to follow instructions. By framing the bad part as just a test, it gives the AI a loophole to prioritize that second command over its own core safety rules. So this all leads to a really fundamental question. Why are we, humans, so good at this? You'd think a computer would be the best at finding flaws in another computer, right? But when it comes to jailbreaking, human creativity almost always has the edge. And this table here just lays it out perfectly. Look at that top row, strategy. Humans bring logic, creativity, real-world knowledge, that unpredictable spark. On the other hand, AI-generated jailbreaks are more about brute force. It's an automated, pattern-driven search. Yeah, they can generate thousands of variations in seconds, but they almost always miss that nuanced psychological angle that a person can just dream up.
So what is it then? What's the secret sauce? What are the specific cognitive tools that we're using that machines just find so hard to copy in this kind of adversarial game? Well, it really comes down to these fundamental ways we think. We use analogical reasoning, which is just thinking, hey, that trick worked on that other problem, maybe a version of it will work here. We use goal-oriented decomposition, which is breaking down a big, forbidden request into a series of tiny, harmless-looking steps. And maybe most importantly, we use iterative reasoning. We try something, it fails, we learn from it, and we tweak our prompt and try again, all in real time.
So all of this, as you can imagine, leads to this constant back and forth, this amazing digital arms race. You've got the developers on one side, building stronger and smarter safety walls. And on the other side, you have this global community of users who are finding these incredibly creative new ways to climb right over them.
And it just creates this never-ending cycle. A new AI model comes out, humans find the loopholes, the developers study those loopholes and patch them up, and that just forces the users to get even more creative. It's this feedback loop that is constantly making both the AI's defenses and the attacker's methods more and more sophisticated.
So, how are developers fighting back? Well, they're not just playing whack-a-mole. They're trying to build systemic defenses. Adversarial training, for instance, is like giving the AI a vaccine. You show it thousands of known jailbreaks so it learns to recognize them. And context-aware detection looks beyond just one prompt and tries to figure out a user's intent over a whole conversation.
But here's the fundamental problem, and this quote just nails it. The very thing that makes these AIs so amazing, their fluid, open-ended, nuanced understanding of language, that's the exact same thing that makes them almost impossible to lock down completely. If you make the rules too strict, the AI becomes clunky and useless. But if they're too loose, it's vulnerable. And that leaves us with the million-dollar question. In this perpetual race between the logical, systematic safety measures of AI developers and the boundless, messy, unpredictable creativity of human beings, who really has the ultimate edge? Is that a race that can ever actually be won? Definitely something to think about.